All right. All right. But that's it for this scatter plot. Any question in regard to this scatter plot? All right.
No, thank you.
And I'll show you later on how to do a scatter plot on ClassCal. Okay, so one of your classmates already kind of started hinting on this. So there are different ways that we could pretty much talk about when we're looking at a scatter plot. So when we're talking about a scatter plot, we're always kind of talking about association. So we want to talk about what type of association does the scatter plot have. So the first one we're going to look at, we're going to talk about a positive association. So the first thing you want to look at the scatter plot is you want to look at the scatter plot and kind of see, does it kind of look like a line? So by looking at the scatter plot, does it kind of look like a line? Like it's not going to be a perfect one-to-one line, but does it kind of resemble a line?
Yes.
Yeah,
Yeah.
if you do a line, like if you look at it, it's close to most of the points. So that's all you're looking for. Does it resemble a line? So the answer will be yes, it does resemble a line. So then what you have to ask yourself, for this line, is it going upward or is it going downward?
Upward.
Yeah, so it's going upward or uphill. So anytime you have your data set, it looks like a line and going upward, we say it has a positive association. So in this case scenario, we're gonna say it has a positive association. All right. So that's a positive association. Somebody already kind of mentioned that in the chat when they say positive correlation. All right, everybody give a positive association.
Yes.
All right, so let's go on to the next one. So for this next one, does this one kind of look like a line?
Yes.
Cool, perfect. So this one pretty much looks like a line. So if you look at it, if I do a line, the points are relatively close to all of those lines. Well, to the line, not to the lines. So if you look at it now, is it going upward or is it going downward?
Downward.
It's going
Down.
downward. So since it's going downward, we said this has a negative association. And that's it for that one. Any question in regard to a negative association?
No.
All right. Oops, this one got cut off. All right, so let's look at this scatter plot. Does this scatter plot look like a line?
No.
Now, if you kind of look at it, it'll all jumble around. Like you can't really tell is the line going over here, is the line going over here. So that's why we call this one no association. Because it's not showing that it's going upward, it's not showing that it's going downward. So that's why we say this is no association, because there's no linear line to it. All right. And that's it for no association. Everybody go for no association?
Yes.
Yeah.
And then we have non-linear trend. So when we talk about non-linear trend, it just means that the scatter plot does not resemble a line. So if you look at this graph I have here, here is the scatter plot. Oops. And then here is the line. So if I look at the scatter plot and if I look at the line, is the line doing a good job on predicting like most of these points? Like,
No.
for the most case, yeah, no, because it's kind of like saying we're trying to fit like a rectangle in a circle. So it just doesn't fit. So what we want to do for this one, we actually want to use the other model. Because if we use the other model, we could get a model that looked more like that. But anytime you're doing a scatter plot, that's kind of like the first thing you want to see. You want to see, does it have the linear trend? Because if it doesn't, you already know you're gonna get something that doesn't work. So why waste your time with something that's not gonna work versus wasting your time with something that will work? All right, so that's nonlinear trend. Everybody good for nonlinear trend?
Yes.
Yes.
Okay. So up next, we're gonna go into correlation coefficient, and the symbol that we use to represent correlation coefficient is R. So anytime I talk about correlation coefficient, or if I talk about R, they're one and the same. All right. So when we use correlation coefficient, is telling us how strongly does our scatter plot look like a line. So for this one, the closer it is to -1 or +1, that's telling me it looks like a line. So the only reason we have a negative and a positive, if you kind of remember back when we were doing association, a -1 represents that you have a negative association. If you have a positive one means you have a positive association. So for this one, when your R is close to either -1 or +1, you're just gonna say, okay, that's a strong linear correlation. When you have a weak linear correlation, it's when it's close to 0. So for this one, the closer it gets to 0, the weaker of an association you're gonna have. The closer it gets to -1 or +1, that's when you have a strong correlation. So let's go back to the scatter plot. And here, let's do a poll. Haven't done a poll in forever. Launch poll. So let's look at this one. So -1, B, 0. So if you're looking at this scatter plot, what do you expect the R value to be close to? Do you expect it to be close to -1, 0, or 1? So if it's -1, say A. If it's 0, press B. If it's 1, press C. All right, so let me show you the result I got. So we'll say N, and we'll say share result. All right, so if you look at most of you says C. So C was the correct answer. So I'm gonna show you why C was the correct answer for this one. All right. So first off, let's look at the scatter plot. For this one, we said a positive association, correct? So
Yes.
if it's a positive association, that means R should be positive. So if you said A, well, that's why A is not correct, because since it's going upward, you should already know it should have a positive number. So you should know A is not one of the answer. So then we're left with B and C. So the reason, so remember, B mean that you have a weak association, so it doesn't look like a line. C represents that it does look like a line. So if I look at the scatter plot, does it look like a line? Well, didn't we say it did look like a line? So that's why it should be C, because it does resemble a line. All right. But can everybody see now why C should have been the answer versus A or B? All right, so let's try this out again. So here's the scatter plot. So all I want you to tell me, should it be close to -1, which is A? Should it be close to 0, which is B? Should it be close to 1, which is C? So let's do the poll, or relaunch poll. And I'll give you a minute to fill this out. All right, so let's stop this poll. Let's share. So if you look at 100% of you said A. So let's look at it. So yeah, so if you look at it, since it's going downward, you know it should be a negative association. And since if you look at the scatter plot, it looked like a line. So yeah, so it should be A. So A is your correct answer. Good job. All right, so let's do this last one. So once again, all you have to do is tell me, is it A, which is -1, is it B, which is 0, or is it C, which is 1? All right, so let me end the poll. Let's share the result. So if you look at it, 95% of you says 0, 5% of you says C. So let's see what the answer is. So if your R is close to 0, that means you can't really see you can't really see a linear line. So if you look at the scatter plot, you can't really see that there's a linear line here. So the answer for this one should have been B. So good job. All right. All right, so that's what the correlation coefficient or R is trying to do. It's trying to see if we have a strong fit or if we don't have, or if we have a weak fit. So if you look at this example, so for this one, we have this example, and this is an example of R is equal to 1. Because if I were to draw a line through these points, let's try that again. If I were to draw a line through these points, pretty much this line goes through every single point. So this is when R is equal to 1. But now if I go to this next one, if you look at it, I can still draw a line through every single one of these points. The only thing different, instead of it going uphill, now it's going downhill. So since it's going downhill, this R is equal to -1. So you kind of know like -1 and +1, pretty much they both mean the same thing. It means we have a strong correlation. The only thing different, one of them is saying that you have a negative strong correlation. The other one saying you have a positive strong correlation. All right, so let's move on down. All right, so we're gonna get into this formula. So the formula is pretty nasty, but we could do it. So when we talk about n is how many points do we have? So how many points do we have? So what I mean for that, because pretty much to make a point, you need an x and a y. So if I have an x and a y, that means I have 1 point. So that means n is equal to 1 if I only have 1 point. So if you have an x and a y, it doesn't count as 2 points. It just count as 1 because essentially the x and the y make one coordinate. So that's how you want to think about n. So say if I go back to, here, let's go back to the very original scatter plot I did. So if you look at this one has, let's do a different color. Let's do green. It has 1, 2, 3, 4, 5, 6. In this case, n will equal to 6 because I have 6 points. But also what you could do, you could go, there's 1, 2, 3, 4, 5, 6. So that's where the n is equal to 6 come from. It's telling you how many coordinates do you have. So that's what n represents. So it doesn't represent how many total data set we have. It corresponds to how many total points do we have. Okay. Everybody good for n? All right, everybody good for n. So up next, we have this symbol right here. So if you look at this one means sum. And if you look at it right here, since we have the x and the y side to side from each other, anytime you have two variables that are right next to each other, that means you're gonna need to multiply. So pretty much for this one, in order to get this value, we have to get x, we have to multiply it by y. Once you get x and you multiply it by y, you add up all the numbers. And that's it for that one. Any question on how to get summation of x, y? All right, so let's try this one. For this one, how do you think we should find summation of x? So I know you know this.
Is it summation times x?
But not summation times x, it is summation of x. So for this one, add x. So all you have to do, add up all the x variable. So when we say summation of y, we add y. So all you have to do is add up all the x's, add up all the y. Right. So let's go on to the next one. So the next one should be summation of x squared. So for this one, if you look at it, first you have to get all the x value, you square them. Oof, sorry about that. You get all the x value, you square them. Once you square them, you add them all up. So add all x squared. And same thing go for this one, summation of y squared. You add all y squared. All right. So that's pretty much all you need to know for this formula. Like, because once you get all of these little components into the formula, it should be pretty easy to do. But you just kind of just know the different symbols. So that way, once you have to substitute it into the formula, it's very easy to do. All right, so up next, I'm going to go over some basic thing about R value. So the first thing said, changing the order of the variable does not change R. So what that means is saying like, it doesn't really matter which one you label as X and Y. I can mislabel them and my R value will still be the same. So for this one, it doesn't really matter which one you label as X and Y. When we go over on the lecture on Monday, in that case, for the lecture on Monday, it does matter if I switch the X and the Y because it will drastically change my value. All right, so the second one says, adding a constant or multiplying by a positive constant does not affect the R value. So kind of think about it. Say we have this scatter plot. But say if I get the scatter plot and now move it over here. Did anything change about the scatter plot about like how does it look? Like no, nothing changed about the scatter plot. Like the only thing that changed is the location of the scatter plot. Like I can move it over here or I can move it over here. But if you look at the shape of the scatter plot, it either still resembles a linear line or it really doesn't resemble a linear line. In our case scenario, it still resembles a linear line. So whatever the R value is, it's not going to change. So that's what the second bulletin point is saying. It's saying it doesn't matter if I add a value to R, or sorry, add a value to X or Y. Like as long as I add the value to all of the X's or all of the Y, like my R value shouldn't be affected. Right. Up next, R is unitless. So R has no unit. Once you find R, it just represents R. It doesn't represent like mile per the hour or your height in inches. It pretty much just is R. And lastly, R is only useful to measure a linear trend. Always graph your data first before computing R to make sure the association is linear. So sometimes you're gonna have cases where your scatter plot just look like a shape that isn't linear. So if you already know your shape isn't linear, it doesn't really make sense for you to do the R value. Because pretty much if I already know it's non-linear and R just tell me how linear does it look, then there's no point to doing R if I already know it doesn't even look like a linear line. All right, but those are all of the key facts in regard to R. Any question in regard to R so far? All right, and we'll get to the rule of thumb a little bit later on. Like we'll come back to that. All right. So let's go ahead and do our very first problem. So for this one, it says the score of 12 students in the math and physics classes are as follows. So if you look, I say math is the x-axis, I say physics is the y-axis. So what we're gonna do, we're gonna create a scatter plot. So first let's create a scatter plot. All right, so we're gonna go backward. All right, here. Go. All right, so let's go ahead and graph this. So first one is 2, 1. So that's over here. Second one, 2, 3. 4, 2. 4, 4. 5, 4. 6, 4. Then we get 6, 6. Then we get 7, 4. We get 7, 6. 8, 7. We get 10, 8. And lastly, 10, 10. All right, so that's our scatter plot. Everybody good with that scatter plot?
Yes.
All right, cool. So let's look at the scatter plot. So what we're gonna do, we're gonna make a prediction. So we're gonna make a prediction of what we should expect our R value to be. So prediction for our R value. So for our R value, should we expect it to be positive or should we expect it to, ooh, sorry about that. Should we expect it to be positive or should we expect it to be negative?
Positive.
All right, so we should expect a positive R value. So if you had a guess, will you think that this R value, like, is it closer to 0 or is it closer to +1?
Closer to +1.
So we'll say closer to positive. So we'll say closer to +1 because we're saying closer to +1 because it looked like a linear line. If it would just look like all over the place where the points were just like scattered everywhere, then you probably would have said it's closer to 0. So, all right, so this is our prediction. Our prediction that we should get a positive value and it should be closer to +1. So now we're gonna go ahead and see, we're gonna go see if our prediction was correct. So we're gonna do this now. All right, so for this one, what we're gonna do, we're gonna find the correlation coefficient and comment on the strength of the correlation coefficient. So when I say comment on the strength, that's that table that I skipped. So we're gonna go back to that table. All right, so let's go ahead and let's fill out this table. So if you look at this table it says x times y. So what I'm gonna do right now, I'm gonna do x, I'm gonna multiply it by y. So I'm gonna do the first one here, but then I'm just eventually gonna just do it all in my head. So if you look at it, you get 2 times 1, you get 2. You get 2 times 3, you get 6. So you get 4 times 2, you get 8, 16, 20, 24, 36, 28. Ooh, that's 42. 6. Yeah, 42. Oh, 8 times 7. 56, 80, and 100. All right, so we're all done for column 1. So let's do column 2. So let's do x squared. So for this one, you literally get every x value and you take it to the second power. So you get 2 to the second power, you get 4. You get 2 to the second power, you get 4. 4 to the second power, you get 16. 4 to the second power, you get 16. 5 to the second power, you get 25, 36, 36, 49, 49, 64, 100, and 100. All right. So that's how you get the x squared. Lastly, we're going to do y squared. So let's pick a different color for y squared. So you get every y value now, and you take it to the second power. So you get 1 squared is 1. You get 3 squared, you get 9. You get 2 squared, you get 4, 16, 16, 16, 16, 36, 16, 36, 49. Oops, I've been doing this all wrong. Hopefully you weren't copying. So you get 16, 16, 16, 36, 16, 36, 49, 64, and 100. All right, so that's how you get these columns. So you'd have to do some multiplication. So x times y, x squared, and y squared. It should be all good. All right, everybody go with these columns.
Yes, sir.
All right, cool. So now we're gonna now do this part of the formula. If you remember, this part of the formula means to sum. So what I have to do now, I have to add up all of these numbers. I have to add up all of these numbers. I have to add up all of these numbers, all of these numbers, and lastly, all of these numbers. So we have to sum up all of those numbers in those columns. So take a minute and add them up. All right. Everybody good on the number, or are all of these numbers fine? Like, I didn't miscount or misadd anything.
Oh, we're good.
So up next, what I want to go ahead and do, I just want to label everything. So what's my summation of x? What should I put for summation of x? And remember, guys, if you don't want to like open up your mic, you can just type it into the chat. There you go. 71. What's my summation of y?
59.
59. There you go. What's the summation of xy?
418.
There you go. What's the summation of 499?
499.
So that's 499.
Yeah.
418.
Oh, you're behind.
363.
All right, and there we go. So you kind of want to do this because once you enter it into the formula, this will make it so much easier for you, because that way you can just pretty much just grab and pretty much pop them into where do they go. Lastly, for this one, what's my n value? So how many total points do I have?
12.
12.
Oh, there you go. Perfect. All right. So we're all good now. So let's go ahead and just get the formula now. So let me go ahead. I'm going to copy and paste this formula. Yeah. All right, so if you look at the formula, the first thing the formula said is n. So let me put n. So you put 12. Then if you look, it says summation of xy. Summation of xy we said was 418. And then we subtracted by the summation of x, which we said was 71. And then we have summation of y, which we said was 59. Then what you want to go ahead and do is divide this by radical, and then you put bracket. If you look right here, it's n. N in this case was 12, so you put 12 again. If you look at this one, it's summation of xy, which is this one with 499. And you subtract it. So one thing I do kind of want you to notice, look at this one and look at this one. They are different from each other. Students sometimes think they're the same, but they're not, because the thing is, if you look at one of them have the parenthesis. So this one over here, you actually want to get 71, and you take that to the second power. So be careful with that one, because that one students do trip up on that one because they think it's the same as 499, which is not. All right, so then we put bracket 12. So summation of y squared, which is 363, minus summation of y, which is 59, and you square it.
Question, how do you get 12 again? I know it's from the like n equals number, but like where did you get 12 from?
So 12, you get it from this. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 points.
Oh, okay, thank you.
Yeah, no problem. All right. Everybody good with this so far?
Yes.
Yes, sir.
Yes, sir.
So what we're gonna go ahead and do, I'm gonna go ahead and switch over to class count, and we're gonna do this in class count. All right. So if we go to class cow, let's bring up my thing. Here, let me move this up. Yeah, I'll show you in a bit. Let me minimize this. All right, so first thing you want to do, you want to hit the fraction button. So on the top, you're going to do this. So you're going to do 12. And then if you look at it, it says 12 parentheses 418, but parentheses just mean multiplication. So you say multiply by 418. And then you say minus 71 multiply by 59. So that's pretty much what goes on top. Any question on anything that goes on top?
No, sir.
All right, so let's do the bottom. So the bottom, it says radical. And then if you look at it, I have a bracket. So where I have the bracket, I'm gonna put a parenthesis. So you put parentheses, 12 multiply by 499. And then you go minus 71. And if you look right here, right next to the 1 to the left of 1, it says x squared. So you put square. And then you want to put close parenthesis. And then you say multiply by open parenthesis 12 multiply by 363 minus 59. And you square it, you close the parenthesis, and we're done. So for this one, you do kind of want to be careful with the parenthesis and with the multiplication. So if you look at the R value we got R, oops, we got R is equal to 0.9085. Any question on how I got that value?
Where'd you find the fraction bar again?
Oh, the fraction bar is the division sign. And so in mine, if you look at my number 9, it's to the right of number 9.
Okay, thank you.
Yeah, you're welcome. All right. Everybody good for this?
Yeah.
All right.
Yeah.
I'm going
Yes,
to
sir.
transfer back to my notes and we're going to finish out this problem. All right, so we get R is equal to 0.9085. So if you kind of remember when we made our prediction, here was our prediction. So our prediction was that R should be positive and that it should be close to +1. So let's go back to our R value. Was our prediction pretty close?
Yes.
Yeah, because we said R should be positive and we got positive 0.9085. And we also said it should be close to 1, which 0.9085 is close to 1. So the last thing we're going to do, we're going to do the strength of this. So we want to see how strong of a relationship do we have. So to see how strong of a relationship we have, I'm going to go back over here to this table. So we got R is equal to 0.9085. So if you look right here, it says R, but it says R absolute. So the absolute value just means anytime you have a positive or negative, you just automatically change that value into a positive. So that's what the absolute value of R is. It is saying no matter if R is positive or negative, you change it to a positive value. So all we want to do is figure out where does this value fall? Does it fall right here in A, B, C, or D? So let's do a poll real quickly. So where does that R value fall? Let's share this. All right, so for the most case, most of you chose A, which A is correct. Because if you look at it from 0.7 to 1, pretty much 0.9085 fall between those two values. So it pretty much gets sandwiched in between those two values. So for this one, you do kind of want to know like inequality. So that way it can make it easier on you to kind of figure it out. Because pretty much 0.7 is kind of like saying 0.7 to 1. So you want to see any number between 0.7 and 1. Pretty much that's where your R value would go. So since my R is 0.9085, that's why it would go in the first column. So if you look at the first column, it said we have a strong correlation. So that's how we know the strength of it. So the strength of this one will be R is a strong correlation because it's between 0.7 and 1. What if this would have been a negative 0.9085? Would that change the answer?
No.
No, because if you remember, we said we take the absolute value of R. So if I take the absolute value of negative 0.9085, you get 0.9085. So that wouldn't change your answer at all. So that's why if you look in the middle, that's why I have absolute value of R, because R could sometimes be negative. So if it is negative, you change it into a positive. So let me go back down. Right. Is strong. All right. And that's it for that first problem. Any question in regard to that first problem? All right, so some of you were asking, is there an easier way to do this? The answer is yes. So the way that we could do this is by using ClassCalc. So I'm gonna transfer over to ClassCalc. So that way I could show you how to do this. Also, if you saw the video that I said to watch for today's class, pretty much that should have given you a little head start on how to do it on ClassCalc. All right, so in ClassCalc, I'm gonna go right here where it says plus sign, and I'm gonna do a table. So if you look at it, you have X1 and Y1. So X1 gonna be for my X variable, my Y is gonna be for my Y variable. So right here, what I'm gonna do, I'm gonna enter the score for math. So we're gonna do 2, 2, 4, 4, 5, 6, 6, 7, 7, 8, and 10. And one more 10 for goodness. All right, so that what X1, that what we put for X1. So what we put for Y1 is 1, 3, 2, 4, 4, 4, how many 4? 3, 4, and then 6, 4, 6, and 7, 8, and 10. Sweet. All right. So if you look at the magnifying right here, if I click it, it will show me directly the scatter plot to the right-hand side. So you can see the scatter plot. All right. Any question in regard to this so far?
No.
So the cool thing about this, if you wanted to recreate the table that I put where it has like X times Y and then where it has X squared and Y squared, you can actually do that in this one. Okay, if you look right here where it says add, you can add, and you can say X1, and then you can say multiply by Y1. And if you look at that, it will do the multiplication for you right here. Then if you go add again, then you can just say X1 and take that to the second power. And then if you want to do add again, you could say Y1, and now you could take that to the second power. and that would give you all of your y1 square. So if you look at it, this will give you all of the data points that we had to calculate by hand. So if you do this in ClassCalc, like it'll give you all of this, it'll give you the whole table for you. Any question in regard to that so far? All right,
No.
so let's go over here. So that's if you want x1 times y1, so on and so forth. But like when you truly want to focus on in this stats button, so you go to stats, you go to advanced. So if you remember, like for the last section, we were using 1 bar stats because we only have one data set. But now what we're gonna do, we're gonna transition over to 2 bar stats because now we have 2 data set. We have an X data set and we have a Y data set. So we're gonna say 2 bar stats. And now we're gonna say which one are my 2 bar stats. So my 2 bar stats will be X1, but it will also be Y1. And if you look right here, well, I don't know if you can see it on my screen. Hopefully you can see it on your screen. If you look at the very first thing they give me is a summation of X, which is 71, summation of Y, which is 59, summation of X squared, which is 499, summation of Y squared, which is 363. And then if you go kind of in the bottom, all the way in the bottom, you see right here where it says summation of XY, which is 418. And if you look right there, it says N is equal to 12. But more importantly, if you see all the way in the bottom where it says R, it says R is equal to 0.9085. So this will literally do everything for you. So if I ask you to just get these summations, like do a 2 bar stats and it will give you the summation. And then you enter into the formula and then don't even do anything to the formula and you get the R value. And it would be easy as that. All right. Everybody good on how to find the R value using ClassCalc? All right. So let's go ahead and do the notes. And we're gonna do this very last problem. And we're gonna use ClassCalc in order to help us do the last problem because it's a pretty big problem. All right. All right, so hopefully you know about credit score. Well, if you don't know about credit score, you're gonna learn about credit score right now. So it said your Fair Isaac Corporation FICO credit score is used to determine your credit worthiness. It is used to help determine whether you qualify for a mortgage or credit, and is even used to determine insurance rate. FICO score have a range of 300 to 850, with a higher score indicating a better credit history. The given data represent the interest rate in percent a bank will offer on a 36-month auto loan for various FICO score. Cool. All right, so these are your credit scores. So pretty much the higher your credit score is, that means pretty much the more likelihood that somebody has good credit. The better the credit you have, like the better interest rate you're gonna get. The worse credit score you have, like the higher interest rate you're gonna get. So for this one, we have our credit score and we have our interest rate. So before we even get started, well, for part A, what we wanna do, we wanna figure out which one should be our explanatory variable and which one should be our response variable. So let's do explanatory variable. Which one should be my explanatory variable? Credit score or interest rate?
Credit score.
Perfect. Good job. So let's say credit. So let's do the response. So if credit score is my explanatory, that means my response automatically is interest rate. Everybody good on A?
Yes.
Mhm.
So what we're gonna go ahead and do, we're gonna go ahead and do B.
Yes.
But for B, what we're gonna do this in class count. So I'm gonna go ahead and transition over to class count. All right, so let's go ahead and do a table. There you go, my table. So we'll put 545, 590, 640, 675, 705, and 750. So let's go our Y. So our Y will be 19%. It will be 18%. It will be 12%, 9%, 7%, and 5%. So if I want to look at my scatter plot, I put it here in the magnifying glass, and it'll take me to my scatter plot. All right, so let's look at the scatter plot. So for this scatter plot, like, how does it look like? Does it look like it could give me a negative correlation, or does it look like it could give me a positive correlation?
Negative.
Oh, negative. For this one, does the scatter plot look like a line, or is it all scattered all over the place?
It gives you a line.
Line.
Yeah, line. So we should expect a value near -1, correct?
Correct.
Yeah, because it's going down.
There you go. All right, so up next, we're gonna go ahead and do, we're gonna go ahead and do a next one. So for this one, we're gonna go to stats, we're gonna go to advanced, and we're gonna go right here where it says 2-bar stats. So for 2-bar stats, we're gonna say X1, and then we're gonna put Y1. And let's get the R value. So if you look at my R value, we get R is equal to -0.979. There you go. R is equal to -0.9793. All right. So since we got an R value that close to -1, so is it pretty safe to say that there is a linear relationship between credit score and FICO score?
Yes.
Yeah. So it's
Yeah.
a linear okay. And you're done with this problem. So to kind of show you, like, it doesn't really, like, if you remember in the beginning while we were talking about R, I tell you, like, it doesn't matter if we switch them around, you'll still get the same thing. So let's test that. So right here, I'm gonna put Y1. Right here, we're gonna put X1. So if I go all the way in the bottom, if you look at it, we get exactly the same thing. We get -0.9793. So just kind of showing you, it doesn't matter the way you arrange it, you're still gonna get the same X and Y variable. Oh, sorry, you're still gonna get the same R value. All right. So that's it for that example. So let's go ahead and switch over to share. All right, so this is what I put for the answer for part C. For part C, we put -0.9793. And then for part D, we'll put a linear relationship, or a linear relation exists between the FICO score and interest rate. All right, so let's do this final one. So let's do the last poll of the day. So just tell me which of these four R value will be considered the strongest. A, which is 0.12. 2, which is which is B, which is 0.42. 3, which is C, which is 0.78, or the last one, which is D, which is negative 0.92. All right, so let me share it with you. So if you look at it, we had D with 50% of the people choosing D. And then we had C, which was 44% of the people choosing C. And we have 6% that chose A. So let's go over this problem. So remember, the closer it is to -1 or +1, we say for both of these, they're strong. Let's look at 0.12. Is 0.12 close to -1 or +1?
No.
Yeah, no. You're not target. So yeah, so no. So you're gonna go no. What about 0.42? 0.42 is close to -1 or +1.
No, sir.
Cool. So no. What about 0.78? Is 0.78 pretty close to -1 or +1?
Yes.
Yeah. 0.78 is pretty close to +1. What about -0.92? Is -0.92 pretty close to -1 or +1?
Yes, sir.
Yeah, it's close to -1. But which one's closer to -1 or +1? Is 0.78 closer to +1 versus -0.92, which is closer to -1? Like which one's closer?
-0.92.
Yeah, -0.92. So that way, -0.92 should be considered closer to it versus 0.78. Like both of them are strong, but if we're looking for which one's the strongest, it will be -0.92 because it's closer to -1 versus that. All right, but that's it for that. Any question in regard to the last one?
No, sir.
No.
Great. All right, so today, that's it for today's lecture. So for today, what I'm gonna let you do, I'm gonna let you out early today. So that way for the activity, you still are responsible for the activity, but I just kind of want to give you a break since especially yesterday you had the exam. So I just kind of want to show you where the new stuff are at, because I added some bunch of stuff because now since we're going over to the second exam, so I added some more stuff for the second exam. Cool. So here are your new activity. So these are activity for the second exam. So for today is activity number 7. For your homework, you want to click right here, linear regression for chapter 12. You click right here. And if you look at it today, we did correlation coefficiency. So this is your homework for today. So technically you can get started on this today. So if you have time, get started on that today. So also remember on Monday, you're gonna have your quiz. So this is where you're gonna find your new quiz. So if you go quiz 6, 7, 8, 9, 10, and if you look, you just have to press that. And on Monday, it should become available. For the quizzes, like I've been noticing some of you need a little bit more time. Like how much time do you think will be a good amount of time for you to be able to do it and upload the quiz?
How many minutes do you usually give us? Like 20?
Yeah, you give it like 20 minutes.
So like maybe 30? Because it takes like 10 minutes alone to just upload it.
Okay.
Yeah, that's true.
All right, so I'll give you 35 minutes to do it. So I'll put that, I'll make sure to do that before Monday quiz. So I'll do 35 minutes.
Thank you.
And also, if you go over to content, I kind of simplify a little bit. So I put week 1, week 2, week 3. But if you actually click, so say like week 2, pretty much that's where you'll find week 2 notes, week 2 note solution, and that's where you'll find week 2 lecture video. So all you have to do, you click on that week, and all the information for that week will pop up. So like for week 3, right here are week 3 notes. So you want to go here to be able to see the notes for next week. All right, but that's it. Any other question before I close out this meeting?
I do. You said that our homework was due at 11:59, right?
Correct.
But would that include the activities as well? Because yesterday I tried to submit it and it said it was due at noon yesterday.
For the activity, yeah, I could go back and I can make the activity due today at 11:59.
Okay, thank you.
Yeah, no problem. Any other question? And somebody had a question about the exam being graded. I should grade it this weekend. So yeah, so somewhere this weekend I should have them all graded and mailed back to you.
Are you going to be posting the solution so we can check on it?
Yeah, I'll be posting the solution. Like I'll post the solution up today. Any other questions?
Did you get my email about the exam?
Here, let me double check my email right now. Like you turning in the exam?
It was just one question that I turned in. I turned in the full exam, just one question I turned in because
Oh yeah. I got that email saying that like you forgot to submit. I think it was for the medium or something like that.
Yeah, for number 6, the median.
Yeah, no, I got that one.
Okay.
I emailed you my whole exam because it said it was too big to submit on the upload it. It said it was too big, so I just emailed it to you.
And you did convert it to a PDF file?
Yeah, it was a PDF.
That's strange. Okay, yeah. No, I got it.
Okay, thank you.
And the homework's due today?
Yeah, the homework is due today for chapter 1 and I think chapter 2. Yeah, so all of the homework for chapter 1 and chapter 2 is due today. Any other questions? All right, so have a good weekend. I'll see everybody on Monday. If you have any questions, email me. I'll try to get back to you as soon as possible. Have a good weekend.
Thank you, you too.
You too.